Good afternoon to all. Am I audible? Am I audible? Good afternoon to all. Am I audible? Am I audible? Low voice. Am I audible now? Am I audible now? Very low voice. Okay. Am I audible now? Am I audible? Is my voice clear now? Is there disturbance? My voice is audible or not? Is it low voice or is it audible? Some of you are typing no ma'am, some of you are typing yes ma'am. I didn't understand. Voice is clear. If it is clear, just type clear. If my voice is clear, just type clear. Type clear in the chat box so that I will be able to know that my voice is clear. If there is disturbance, type disturbance. If it is low, type low, because I am using some other channel for my voice. Clear? Okay then, because in my laptop there was too much noise. Still, are you able to hear the noise? I have made some modifications in the software that I have been using so that it will be easy to take the class. So I hope today the class will go smoothly. I don't know. Okay. So let us start the class. Once again, I'll start with principle of operation of DC generator. If there is double voice or disturbance, still disturbance is there. Some of you are typing clear voice, some of you are typing low voice, some of you are typing disturbance whatnot. So I don't have clarity. So I'm continuing the class. So principle of operation of DC generator. So we have already discussed it. Once again, from yesterday's class onwards, I am going to repeat whatever I have discussed yesterday. Same thing I am going to repeat here. So if you have low voice, you wear earphones so that you can hear my voice. So I am about to change my device. I have issues with my laptop. It is 10 years old. So maybe because of that, the drivers are not supporting this OBS software. I have even installed some other software in my laptop, but I thought let me check this. If there is any issue, I'll proceed. So if my screen freezes, please type in the chat box that my screen has frozen because I am out of the actual page from where I have been displaying the screen. So I will start the class. So I will start the class. So we have been discussing from yesterday onwards same thing. So whenever the conductor is moved in the magnetic field, what will happen is there will be rate of change of flux linking. With respect to time, the flux linking with the conductor will change, and hence voltage will be induced across the conductor terminals. If magnetic field is if the magnet is moved around the conductor or conductor is moved in the magnetic field, in both the cases, please wear the earphones. If my voice is too low, please wear the earphones. Anyone who is able to hear my voice, please mention clear in the chat box so that I will be able to know that my voice is clear. Some of you, anyone? Is my voice clear? Shall I switch to the previous device in which there was so much disturbance was there? Is my voice clear or is still? Earlier someone typed that my voice is clear. Yes ma'am means I won't be able to understand what is meant by yes ma'am. I want to know whether my voice is clear or not. Not clear? So I will switch to the actual device which I always use, that is my laptop. Okay, okay. Now I have connected to my laptop. So I have connected myself to the laptop. So maybe you can hear some disturbing noise behind my voice, but I think you will be able to hear my voice clearly. Is it okay now? There may be some disturbing sound, some fan sound or something. Are you able to hear my voice now? Are you able to hear or not? Please mention. Are you able to hear my voice? How is my voice now? Is there disturbance? Is there disturbance in my voice? There is disturbance. I can hear. I have another device in which I have connected myself. There is disturbance, but you people can hear my voice, isn't it? You are unable to hear my voice, but I am able to hear my voice in my other device. Anyone else who is able to hear my voice? Voice is low. Please increase the volume of your device. It's not connected. If my screen freezes, please inform. If screen freezes, please inform. Please increase the volume of your device. Because in my other system, I am able to hear my voice. I have logged into another device as a viewer, as a spectator, okay, as a student, you can say. Okay, I am going to continue the class. You just note it down. Okay, then I am just going to start the class. So here, as the magnetic field, if magnetic field is moving with respect to the conductor in this case, or if conductor is moved with respect to the magnetic field, either may be the case, what will happen is voltage is induced. Okay, so in this case, in the first case, what happens is conductor is stationary. Conductor, this is our black line, is our conductor. Conductor is stationary, magnet is moving, means magnetic field is moving. So in the second case, conductor is moving. See, you can see here movement. Conductor is moving, whereas magnetic field is stationary. So either one of these two will be stationary, one will be moving. So what will happen is EMF is induced. If those conductors, if whatever conductor here is here, if it forms a closed path, then EMF, if it forms a closed path, because of the induced voltage, what will happen is current will flow in the conductor. So the principle of operation of generator is that whenever the magnetic flux lines that are linking with the conductor or a coil, here I am showing you only one conductor. There can be n number of conductors connected to form a coil. I hope you know what is meant by a coil. I am drawing it simply roughly I am drawing something, so I hope you know what is meant by. Okay, someone has written something. So okay. Okay. So it's not the issue with the mic. It's not the issue with the mic, okay? So someone has typed something. It's not the issue with the mic. It is the issue with the laptop that I have been using, okay? So because of the laptop and the software that I have been using, because of the software that I have been using, voice may not be clear, okay? So I will check the volume. Okay, it's not the issue with the mic, okay? So you people, if you use this software, you will come to know what is the issue with the mic, whether it's the issue with the mic or not. So still you are unable to hear me? Are you able to hear me or not? Are you able to hear me? Is my voice audible? Still, is there any issue? Because I am able to hear my voice, I don't know why you people are unable to hear. If you want, you can hear my other. Are you able to hear me or not? See, this is being recorded, isn't it? So you can later check in the channel when it is being recorded. So someone has typed something rubbish in the chat box, okay? So it's not a joke, isn't it? If you are unable to hear, that means you might have some issue. Mine is a good mic, okay? So it's an Sony company mic, okay? So you can, I think I have made you hear the voice of the other system in which I have logged in. So let us continue. Once again, I will start and I will continue. Because I have good internet connection, you can see there it is showing excellent connection. That's good. That's good to take the class. So principle of operation of generator is what? So it works on the principle of Faraday's law of electromagnetic induction. So whenever number of magnetic lines of force that are flux lines with a conductor or a coil change, okay, this means the flux linking with the conductor or a coil change. Maybe the flux is moving or the conductor is moving. What will happen is electromotive force is developed in the conductor. Okay, so there should always be a relative motion between the conductor and the magnetic field. So if there is a relative motion, then only EMF is induced, otherwise EMF is not induced. So you can see here in this diagram which I am showing you here, there is only one coil. There is only one coil. Okay. So only one turn is there in the conductor. Conductor has been twisted in the form of a coil. Only one turn is there. So n number of conductors can be connected in such a pattern that they form some n number of coils. So you can see here, this is one turn of the coil, next second turn and third turn. Total 3 turns are there. Okay. So total 3 turns means here 3 coils are there. The number of coils here is 3. There can be more than 3. So this is a single turn coil. This is a single turn coil, whereas this is 3 turn coil. There will not be single turn or 3 turn coil. There will be n number of turns in the coil that is placed in between the magnets. So you can see here a north pole. You can see here a north pole and a south pole. Okay, there is a north pole and a south pole. So in order to, what if there are opposite poles, then what will happen? There will be magnetic flux lines traveling from north pole to south pole. Okay, magnetic flux lines will be traveling from north pole to south pole. Okay, so these flux lines, even though the magnetic field, even though the flux lines are traveling from north pole to south pole, here the flux is made stationary. We want one to rotate. Okay, either the flux should rotate or the coil should move or the flux should move. So here what I am going to do is I am going to rotate the coil, keeping the magnetic field stationary. So if the coil is rotated, the coil will cut the flux lines and hence EMF is induced in the coil. Okay, so EMF will be induced in the coil. Now this induced EMF is proportional to what? This induced EMF is proportional to the rate of change of flux linking with respect to time. The rate of change of flux linking with respect to time. Okay, so linking with what? Linking the coil with respect to time. So the induced EMF is proportional to d phi by dt. So this is it. Write it down. E is proportional to rate of change of flux linkage. If you remove the proportionality, it is replaced by a proportionality constant n, where n is the speed. N is the not speed. N is the number of turns in the coil. So you can, as I have shown you in this diagram, as I have shown you, there are 3 turns. Okay, there are 3 turns, 1, 2 and the third one 3. Okay, total there are 3 turns. I am unable to write that. Okay, there are 3 turns. There can be more than 3. So n number of turns will be there in the coil. So okay, so n is nothing but number of turns in the coil. So E is equal to what? The induced EMF will be equal to number of turns in the coil into rate of change of flux linkage into rate of change of flux. So voice is clearer. I can hear, of course there is disturbance because of the system that I am using behind my voice. So if you are unable to hear my voice, maybe your volume in your phone or whatever you are using, the volume of your system is low. Okay, so okay then. Now in order to rotate this coil, I'm once again I have taken a single coil here, single one turn coil, only one turn coil. This is known as, this is whatever is shown here is a one turn coil. So I'm going to rotate this coil. Why? Because I want relative motion between flux and the coil. Okay, so where is the flux? This is north pole, this is the south pole. So there is flux between north pole and south. Okay, there is flux between north pole and south pole. So there should be relative motion between north pole and south pole, so that EMF is induced. So for that, just for example, now to understand the concept, I am showing you here hand. You can see two hands. Okay, so with the help of hand I am rotating the coil. So when the coil rotates, what will happen? The coil will cut the flux lines while rotating. Okay, when this coil is rotating, you can see it is being rotated in clockwise direction, no, in anti-clockwise direction. In this diagram it is being rotated in anti-clockwise direction. So what will happen? The coil will cut the flux lines, and hence what will happen? EMF will be induced. And if you see here this coil, if you see this coil, it has been connected to some slip rings. These rings are known as slip rings, and these black color boxes, what you can see, are known as carbon brushes. Okay, and they are given, so they are connected to some measuring device. This is some measuring device. So when the coil forms a closed path, what will happen? Current of I amperes, this blue color arrow marks what you can see. Okay, current of I amperes will flow through this coil. Okay, now so what are we doing? We are rotating the coil. Okay, so in this diagram you can see a conductor. Okay, so we are rotating the coil in the magnetic field so that EMF is induced in the coil. Now, so let us assume, if you take your right hand, I can show you another image. You just take your right hand and you just stretch the thumb. Okay, you just stretch the thumb of your right hand. Okay, stretch the forefinger perpendicular to the thumb and stretch the middle finger perpendicular to the forefinger. Okay, so all these three fingers are perpendicular to each other. So these three fingers are perpendicular to each other. So you just hold your right hand, all of you, if you are listening to the class, hold the right hand's forefinger, thumb and middle finger perpendicular to each other. So now, if suppose the direction of motion of the conductor or the coil is given by this thumb, and if the direction of the magnetic field, that is flux lines that are traveling from north to south, is given by this forefinger, then middle finger will represent the direction of the induced EMF. Okay, or the current, direction of the current flowing in the conductor. Middle finger will represent the direction of the induced EMF or direction of the current flowing in the conductor. Okay, so the direction of movement of the coil movement direction. Okay, motion means the direction in which the coil is moving. Okay, the direction in which the coil is moving, that will be perpendicular to the magnetic field direction, and that once again it will be perpendicular to the induced EMF or the direction of the current flow in the coil. Okay, so that can be shown here. You can see here this diagram. So middle finger, forefinger and your thumb are stretched perpendicular to each other. Okay, so you can see this is the direction of the magnetic field. Okay, this is the direction of the induced EMF. So angular displacement between EMF and this magnetic field is 90, and this is the direction of the motion of the conductor, movement of the conductor. Okay, so which is also perpendicular to each other. So okay, this is known as Fleming's right hand rule. Okay, so we can determine in which direction EMF is induced in the conductor by Fleming's right hand rule. Okay, just write down Fleming's right hand rule. So what is our Fleming's right hand rule? If you stretch the thumb, forefinger and middle finger perpendicular to each other, then a forefinger represents the direction of the magnetic field. If thumb represents the thumb represents the direction of movement of the conductor, then the middle finger will represent the direction in which the EMF is induced. Okay, I hope you have understood Fleming's right hand rule. Did you understand Fleming's right hand rule? You can mention in the chat box if you have understood Fleming's right hand rule. So you can see one more image I am showing you here. So this is the direction of motion of the conductor, movement of the conductor direction. This is the direction of magnetic field. This is the direction of induced EMF. Okay. Now, so let us see what is meant by a Lenz's law. There is a law known as Lenz's law. Let us see what is meant by Lenz's law. Now, let us consider a magnet. Okay. We know magnet has two poles, North Pole and South Pole. Magnet has two poles, North Pole and South Pole. So this is North Pole, this is South Pole. Okay, this is a magnet. Okay, this is a magnet. So what will happen? We already know if a magnet is there, what will happen? Flux lines will come out of the magnet from North Pole and they will travel to the South Pole from north to south. Okay, from north to south flux lines will the flux lines will travel from north to south. So someone has written slow. What does it mean? Should I go slowly? I am already teaching slowly. So flux lines will travel. So one thing, I am also an audience like you people. So I am able to hear my voice from the other device. I have also connected myself with my mobile, and in my mobile, along with the disturbance, I can hear my voice clearly. So if you have any issue, if you have issue, I will be able to know, isn't it? Did my screen freeze? I will once check it. And in my mobile, along with the did my screen have freeze? Any issue? If you have issue, I will be able to know, is screen matching with my audio? So what I saw here is it was my okay, whatever. And in my mobile, along again and again, I will check my screen. If you have any issue, if you have issue, not, I will be able to know. Is screen matching with my audio? So once again, I don't know whether you have what I saw here is right hand rule. How many of you heard the Fleming's right hand rule? Okay, just mention in the chat box. Next is slow. Okay. So how many of you have heard the Fleming's right hand rule? And in my mobile, along again and again, I will check my screen. If you have any issue, if you have issue, not, I will be able to know. Let me check. Is screen matching with my audio? So once again, I don't know whether you what I saw here is right hand rule. How many of you heard the Clemens right hand rule? Just mention in the chat. What about now? Double voice. Are you able to hear double voice? Neck is slow. Okay. So how many of you have heard the Clemens right hand rule? And in my mobile, again and again I will check them and give my I will be able to know. So let me check. What about now? Is screen matching with my audio? Once again, single voice. What I saw here is right hand rule. How many of you heard the Clemens right hand rule? Just mention in the chat. What about now? Double voice. Are you able to hear double voice? Neck is slow. Are you able to hear my voice? So how many of you have heard the Clemens right hand rule? Double or single? And in my mobile, again and again I will check them and give my I will be able to know. So let me check. What about now? Is screen matching with my audio? Once again, single voice. What I saw here is right hand rule. How many of you heard the Clemens right hand rule? Just mention in the chat. What about now? Double voice. Are you able to hear double voice? Neck is slow. Are you able to hear from yes? So how many of you heard the Clemens right hand rule? Double or single? And in my mobile, again and again I will check them and give I will be able to know. So let me check. I have disconnected from other device. What about now? Screen matching with my audio. Once again, single voice. What I saw here is right hand rule. How many of you heard the Clemens right hand rule? Just mention in the chat. What about now? Double voice. Are you able to hear double voice? Neck is slow. Are you able to hear from yes? So how many of you heard the Clemens right hand rule? Double or single? And in my mobile, again and again I will I will be able to know. So let me check. I have disconnected from other device. What about now? Screen matching with my audio. Once again, single voice. What I saw here is right hand rule. How many of you heard the Clemens right hand rule? Just mention in the chat. What about now? Double voice. Are you able to hear double voice? Neck is slow. Are you hear from yes? So how many of you heard the Clemens right hand rule? Double or single? And in my mobile, again and again I will I will be able to know. So let me check. I have disconnected from other device. What about now? Screen matching with my audio. Once again, single voice. What I saw here is right hand rule. How many of you heard the Clemens right hand rule? Just mention in the chat. What about now? Double voice. Are you able to hear double voice? Neck is slow. Are you hear from yes? So how many of you heard the Clemens right hand rule? Double or single? And in my mobile, again and again I will I will be able to know. So let me check. I have disconnected from other device. What about now? Screen matching with my audio. Once again, single voice. What I saw here is right hand rule. How many of you heard the Clemens right hand rule? Just mention in the chat. What about now? Double voice. Are you able to hear double voice? Neck is slow. Are you hear from yes? So how many of you heard the Clemens right hand rule? Double or single? And in my mobile, again and again I will